Can you guys hear me now? Nice. All right. Very good. All right. Sorry about the sorry about the technical difficulties here. I can't say I'm perfect. Yeah, I know. I'm glad I could hear me rather than all that static noise. Oh my gosh, that was awful. I'm so sorry, everybody. I feel terrible about that. Takes 5 minutes to finally get sound. Oh my goodness. Bro, you weren't gonna listen to me anyway. It was either that or it was my deterrent. That's what it was. uh, Dude, you don't need to keep asking why you. You should just already know that answer to a rhetorical question. That's true. Um, all right, so welcome back here. I appreciate your time. All right. Thank you very much for coming back. All right. Very, very cool. Here today we're going to be doing section 4.2. All right. So today we're going to be talking about exponential functions. The whole thing is frozen on your screen. Okay. I tell you what. I got an idea then. Anybody else having issues with the screen being frozen or anything like that? Okay. I just want to be sure everybody's on board because I would hate people to miss out. So okay. So I don't want to be like that guy. So okay. All right. Everybody's good to go. So by the way, before we get started here, as I was saying kind of earlier, I know you guys kind of missed out on that part. So let's talk about here that first of all. First thing I want to talk about is the test. I haven't quite made it up just yet. I'm still working through some of the processes online. It will. I'll go ahead and put that on there probably tonight. Still working on it, so I do apologize. It's been kind of a crazy couple of days as I'm still kind of running around here just a little bit. Roommate finally came back. My former roommate finally came back and took some of his things, and things are kind of dirty around the house, and I need to clean it. So, be a good idea. And by popular demand, as was the last case, I did happen to get my Dunkin Donuts. So I really do appreciate that. You guys by popular demand. Dunkin Donuts is in the building. So I went out there today, and I got exactly what you guys wanted. I even got my I got I got my 2 orders of hash browns, and my turkey sausage, egg, and cheese on a croissant. So I know until they close, but still, as long as they're open and I still have the app, then okay. Starbucks, oh man, can't do Starbucks, man. Yeah, this stream should be sponsored by Dunkin Donuts, absolutely. I have no qualms about that. All right, so okay, so let's go ahead and get started here for today on section 4.2. Section 4.2 is going to be dealing with exponential functions. All right, so last time actually we did the end of actually we did section 4.1, but I think I forgot to do just one problem from that section, or one question I should say. So I do want to at least acknowledge that here to start with. So that way we're caught up. So, and that is this last question here that I didn't get a chance to get around to, and that talked about the domain and range of an inverse function. All right, so what is the domain and range of an inverse function? We looked at how to find an inverse function last time. We also found ways to graph inverse functions using our original function. And it's actually not too hard, the domain and range of an inverse function. So the domain and range of an inverse function, kappa to you too, sir. The domain and range of an inverse function. So the domain of f of the inverse of f. So let's go ahead and put that down here. I just need to make that a bit smaller. Good. All right. So the domain of the inverse, let's go ahead and put that down. So the way it works is that everything kind of works in reverse, all right? So if I take the domain of the inverse function here, then the domain of the inverse here is going to be the range of f of x. Okay, so that's the way that's going to work there. All right, so the range of f of x is the domain of the inverse, right? Because we said, hey, we go from x to y, we go from left to right, and this time we just go backwards from, say, y to x from our original xy chart. So basically, the domain of the inverse is the range of, and then vice versa here, the range of this dude is the domain of the original function. So everything gets reversed, you know, everything gets reversed around, and that's how we can go ahead and have that. All right. Okay, so that was the last question there that I just want to acknowledge. There is, if you do get questions there on the homework there, then you'll know you just need to find the domain of the original function and the range of the original function, and then basically kind of swap them around, and those become the domain and range of the inverse function, whatever that may be. Okay, so that was the last question that I wanted to discuss about here last time. So that way, at least you have a good idea, and that'll, kind of put a nice little bow on section 4.1. Are there any questions about that? This coffee is outstanding. Oh man, I tell you, wakes you up in the morning, that's for sure. All right, cool. Okay, so let's go ahead and move on here to the newest section, which I said section 4.2. Unfortunately, for whatever reason, I don't have the notes for it, so I'm just going to kind of make it up on the fly. Now, for most of you, making it up on the fly is pretty much what I usually do anyway. So, yeah, that's usually a thing. Since I usually make it up on the fly, okay, let's keep going. All right, so let's talk about exponential functions first and foremost here. Yeah, I know. Like I said, 4.2 examples are not on Blackboard. That's the only section to get that there. All right. Okay. So first things first here, what is an exponential function? All right, so let's first talk about that. What exactly is an exponential function? That's okay, Maddie, not a problem. All right, so what exactly is an exponential function? Well, an exponential function is going to look something akin to this. So let's put on some basic exponential functions. You have a base here of your exponent, and that exponent could be taken over to, say, the x power. So you could say f of x is equal to 2 to the x, or f of x equals 3 to the x plus 1. Okay. And then you could have, say, g of x is equal to 4 times 3.1 to the, say, 2x plus 7, okay, or something akin to that. Okay, so these are all types of exponential functions. We're going to be just taking a look at some basic ones here today. But you know, I could probably just put in one more here just for some giggles. So over here we got your Animal Crossing still hasn't shipped. This is rigged. Hang on a second. Animal Crossing doesn't ship until tomorrow. That's when the game comes out. All right. So you got 2 to the minus 4x minus 2. All right. Yeah, apologies about that. All right. So here's another. All right. So here's another exponential function, 2 to the 4x minus 1. All right. There you go. There's another type of exponential function. Okay. So all these types, we're going to look at some of these types here today. All right. And we'll see exactly how to work with them in some form or capacity. All right. All right, so let's look at some examples here at the very least, and I'll acknowledge that here in the second question. So let's go to the question 2 here. How do we evaluate exponential functions? All right, so let's just talk about evaluating exponential functions. All right, so we're just going to take some random stuff here, and we'll make up a random function here. We'll see exactly how we can work with that. I'm pretty sure I'll probably need a note for this. So let's start off with something on the basic here. Okay, something not too hard. Let's take 3 to the x power. Okay, so something as simple as, say, 3 to the x power. All right. So let's pick some values here. Let's say x is, let's say I want to take f of 2. Okay. What would f of 2 be equal to? So if I plugged in 2 into that function, what should I get? You put your answers in the chat there, please. That'd be cool. All right, very nice. So again, we take again 3 to the second power, and that equals 9. All right, very good. Okay, good. All right, so not too hard. Okay, pretty simple and straightforward. Let's go ahead and try another here. All right, something. All right, let's try. Let's see, 1.7. Okay, so some of these examples here that you're going to find are going to require you using the calculator, all right? So without question. So yeah, obviously you're not going to know 3 to the 1.7 power off the top of your head, but that's okay. That's not a big deal. Does anybody got an answer for me here? We'll go to 4 decimal places for this. 6.473. Looks like some people are putting 5.1. Oh, I think you accidentally multiplied there, Huma. I think you wanted to take it to the power of 1.7. Do you want to take it? You want to take it to the, yeah. There we go. All right, right on, everybody. Very good. Not too hard. All right, so far so good. Okay, let's go ahead and do another one here. You're probably saying, I know, seems I'm kind of sick and tired of some of these, but some of them will have importance to it. So let's go with -3 actually. All right, so what is f of -3? What happens if we put 3 to the -3rd power? What do we get there? -27. 3 to the -3rd power? Fortunately, not -27. Well, that's a good guess. 3 times a -3 is -27, but 3 to the third power, -3rd power, is not -27. All right, I see some decimals there. So can you guys tell me? Now, I agree with the decimal there, but how about in a fractional format? What would that be as a fraction? Okay, really nice. Okay, good, good. Okay, so, all right. So let's talk about this one here. This is why I put out this example here, because if there's one thing to remember here is going back to our exponential rules. And if we have a negative power, then we do have to convert it over. Okay, so in order for us to convert it over, we have to take it and change it from a negative power to a positive power. Now, of course, there is a consequence for doing so. And that consequence is if we take 1 and then we change that to the 3 to the third power there. All right, so we move it from the numerator to the denominator, and we get 1 over 3 to the third in this case. And that indeed, I agree with everybody there, is going to equal 1 over 27. That's right. So we don't get a negative here. Okay, we do get 1 over 27, and this is going to be the kind of the preferred result. I know you could get easily a decimal equivalent on a calculator. That's really not too hard, but it's important to remember this rule here. So I'm going to go ahead and make a note about this one here. So a big note here. So again, the note that I want to refer to here is the rule, a few rules here, and that is first and foremost, and I'll move this down. There we go. Is that a to the minus n power equals, again, this is one of the important exponent rules to remember, so this is why I'm kind of putting this in. Gives you a nice little friendly reminder about how to tackle things that could be a little bit more difficult in terms of exponents and stuff. So here we got this rule here. Okay, so we got a to the minus n equals 1 over a to the n power. Or again, this also works the other way as well. This also works the other way as well. So again, if you have 1 over, oops, let me go ahead and put that down. So you have 1 over a to the n power like so, 1 over a to the minus n power, I should say. This is equal to a to the n power. So again, you can move from denominator to numerator or numerator to denominator. All right. So there you go. I can't be the only one that's done this. At least I don't think so. Are the completed note sheets? Yes. They are all on, yeah, they're all on Blackboard now, with exception to this section here today. But every other section is going to be on Blackboard, yes. You can find that under course materials. So if you want to go ahead and Okay. How about if it's negative 3 to the third power? Yeah, that's fine. That's fine. So I'll acknowledge it, absolutely. So let's take negative 3 to the third power there. Now, negative 3 to the third power is just fine. So the only thing that you have to be worried about is the negative in the exponent, okay, not in the base. So meaning to say, if this number here is negative, this 3, then we just go ahead and use the rules that we have here over on the note sheet here. But if it's just a regular positive exponent, you can just do negative 3 times negative 3 times negative 3, and in this case here you get negative 27 as a result. Right, so again, it only applies if the exponent is positive, okay? Not if the base is negative or not. So the base doesn't matter, it's really about the exponent at the end of the day. Now there is one more note that I wish to make here, so that way I get a further clarification on certain things, and that is also in regards to, and this is in deference to fractions. So sometimes fractions can be a little bit confusing here when it comes to that. So let's I want to take a look here at a negative exponent here. So if I take a over b to the negative nth power, basically this is going to be equal to, now what happens is that typically, like we use from our note here from before, we move that to the denominator. But if you basically move that to the denominator, you basically flip the fraction over and change the exponent into a positive. So what we get here is, let me get that there. What we get here is we get b over a, because now the fraction flips over, and this time you can take that to the nth power. So notice the difference there in that case is you could take b over a to the nth power there if you have a fraction as a base. So really quick, let's go ahead and give, using that, let's go ahead and give it a try here. Okay, so I just want to give a short little practice run with this. So put up a fraction here for you guys. Okay, so how about 2/3 to the negative 2 power? 2/3 to the negative 2 power, what would that be? Okay, I agree with that. Totally agree with that. So let's go ahead and make that change right now. It'll be 3 over 2 squared. Spot on. And we get what's our final result here? I think that was posted already. 9 over 4. All right, very nice. All right, awesome job, guys. You guys are rocking it. All right, so 9 over 4 would be our answer for that. Absolutely, nice job. Any questions about that so far? And again, if you don't have any questions, by the way, this is what I've been kind of asking kind of everybody, is just go ahead and put no in the chat, so that way I know to move on. Yes. So you always have to flip the fraction then solve. Yes, I do have to flip the fraction if the exponent is negative. So I will use this rule here. So I'll go ahead and use this rule here, and I'll put this with the other rules there. That wasn't supposed to happen, but okay. Technology, this is what I work with. All right, so this is the other rule that you'll have to keep in mind as well. All right, so yeah, you always have to flip the fraction if the exponent is negative. All right, so that's what you're working with there. Are there any other questions? What sections should we study for the test? Um, okay. Sections you should study for the test here will be sections 3.1 to 3.4. I believe. Yeah, 3.1 to 3.4. So that'll be just the test sections there. Yeah. Any other questions? I think you got to do it in one sitting. Um, uh, I think you have to do it in one sitting, but you can take it as many times as you want. I think I'm going to try and arrange it to have it that way. So just confirm there's no due date. Yeah, so there will be a due date for the test. That due date will be the end of the semester. Is there a time limit? No, come on, man. You know I don't do time limits on tests. Never. I would never. I would never do that to you, man. That's not the way I roll. You know that. I will never give you a time limit on test. Yeah, I haven't put up the test yet, so I'll be putting up the test here later tonight. So yeah, man, just like my policy in class, yeah, I'm not going to give you a time limit on your test. Never. Now, man, I want you to work at your own pace, work at your own time. Just keep it as chill as possible. Nah, math shouldn't be about. Math should never be about getting things done in time. Math should be about you guys showing me what you know, and if it takes more time than everybody else, that's fine. You know, don't compare yourself to other people. I'm just happy for the way you are. Like I've said before, um, you guys are what makes this class. You guys are what makes this class very enjoyable. You guys are what makes my job enjoyable is because of you guys. It's not because of me. It's because of you. So, yeah. Uh, I don't think every day you guys lift me up, and I really, really genuinely appreciate that. As much banter as I have going back and forth with you guys, no, you guys have no idea what you guys mean to me in terms of just just having a cool other presence there. You guys offer so many different perspectives, and I really, really appreciate that a lot. I really do. So I want to thank you guys. maybe maybe soon. I don't deserve a donation. You guys should hold on to your money for now. In trying times, please be sure to be sure to save up some money for yourself. Okay, please. Yeah, anytime we look, I'm just gonna tell you straight up truth. Anytime where there's a terms of financial, insecurity at this moment in time, I just try and be as conservative as possible with your money. You know, so I'd love to go spend it on other things, but you know, we don't know what holds in the future. So, always just in case. Some free little advice there. Hey guys, feel free to ask me whatever questions that you want. You know me. I'm like I'm gonna go on an open book. You can't go on a date because stores are closed. You couldn't get a date anyway, so there wasn't a difference between yesterday, today, and 5 weeks ago. I mean, sorry, bro. You should have accepted that reality from the beginning of the semester, but I guess you weren't listening. Anyway, moving on. All right. Oh man, never gets old. Okay. Okay. All right. Next, let's go to question number 3. Uh, Bro, you make it too easy for me. This is like you're like chucking up softballs for me, man. This is just so simple, man. Just bro, what can I do? I'm sorry. I want to apologize if your dating prospects are as thin as my hairline, but that's the reality of the situation at this moment. Okay. All right. Moving on. Okay. So, all right. So next here, uh, when am I streaming Skyrim? Huh, I'm not sure yet. Maybe I'll stream. Maybe I'll do a casual stream at some point. But math class gotta take priority first. Um, all right. Okay. Next is let's go ahead and take a look at question 3. How do we graph exponential functions? How do we graph exponential functions? So that's the next question on the agenda here. How do we graph exponential functions? All right. So we're going to take a look here and talk about some exponential functions. We're also going to talk about properties of these exponential functions as well. All right. So let's take a look here at let's take a look at a basic one here, and we'll call it 2 to the x power. Okay. So that's going to be our function here in this case. All right, so I'm going to go ahead and we're going to look at a little bit of an XY chart. This is going to be kind of a different way of putting up an XY chart. Well, kind of. But let's go ahead and make up some points here. So make a little XY chart here. So I'll put X and Y here respectively. Okay. So let's go over. Let's just try some numbers here. Okay, we're just going to try some numbers, all right? And we're just going to see what we get for y. And then once we get our nice little XY chart like we normally do, then we'll take a look at what the graph is, okay? Simple enough. All right, so if I plug in 0 in for x into 2 to the x, what do we get out for y? Okay, so I see a couple people say 0. See, Josh says 1. Okay. 0. 2 times 0. No. Don't want to do 2 times 0. So in this case here, we're going to use another property of exponents here. The property here is anything to the 0 power, regardless of whatever number it is as your base, is going to be 1. Okay, so we actually get 1 here. Yeah, I know it's easy to say 0. It's it's the first thing that usually comes to mind. I understand that, but that's okay. That's why we cover that there. So 1 is the correct answer. All right. So very nicely done. Very good. Very good. So that's what we get there for the first one there. Oh look, it already put down something for me. All right. So how about this next one here? How about it's not a competition, okay? I promise you. It's just an educational experience. All right. All right. So 1, and if we put in 1, we get 2. Absolutely true. Very nicely done. Very nicely done. I'm going to take out that one there. But if I get minus 1, what do we get here for minus 1? So half, half. Okay, anyone else? 2 to the minus 1 power. Right? All right, very good. The answer is a half. Very good. So 1/2. Okay, very nicely done. I'm going to go ahead and put another couple of guys here. So let's put minus 2. What do we get here for minus 2? All right, very nice. 1/4 is absolutely spot on. Very good, everybody. Very nice, very nice. All right, and we'll go ahead and put in one more here. 2, we get 4, so that shouldn't be too